Alrighty, everybody, I just got the okay to start our planetarium show. And since we're getting ready with our get ready for our show, I'm going to put away our space trivia questions because now we're going to be heading into the unknown. Ooh. And good afternoon, everybody. Welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm actually a person, and I'm standing right behind you. Hey, what's up, y'all? Don't hurt your necks. Look forward into the dome before you. That's where the whole show's going to be. I just want to let you know that I'm here. I'm going to be your space pilot, your planetarium presenter for this afternoon. And I'm very, very excited to be with you because what we're going to be doing right here is by far my favorite show to do in the Morrison Planetarium. This show is called Tour of the Universe, and essentially this show is going to be completely live. You're going to hear my voice for the next 30 minutes, and we're going to be starting off pretty close to Earth, and we're going to be zooming all the way out to the very edge of the observable universe. Hopefully by the end of the show, you won't have an existential crisis of where we are in space, but just a heads up, we are very small in the grand scheme of things, so just want to forewarn you. But before we get started with our planetarium show, I do got to go over some quick house rules just so that we're all on the same page. We have a great experience in the planetarium. First off, there's no food or drinks allowed inside. If you manage to bring any snacks or beverages, make sure those are put away till the end of the show. We want to keep the theater nice and clean. This also does include no feetsies on the seatsies because we just put in new seats about a couple weeks ago. We're trying to keep these seats as clean as possible for all of our future guests. So we do appreciate your help, folks. Also, if you happen to have brought in any electronic devices like cell phones, smartwatches, tablets, anything that produces bright white light or loud sound, now is the perfect time to turn them off, deactivate them, put them away for the next 30 minutes, as these devices can be very distracting, not only for you, but for the folks sitting behind you. So we want to be courteous to everyone in the planetarium dome. And also, folks, if you do need to exit the planetarium for any reason, you're more than welcome to do so. All we ask is that you exit at the very top of the planetarium. That's where the exits are going to be before, during, and after the show. If you're a person that has trouble climbing the stairs, don't worry. Once the show's over, we'll have someone escort you to a lower exit, so just stay seated for a little bit longer. Then we'll help you out then. And last but not least, folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, that's totally normal. There's a really quick and easy trick to ground yourself. All you got to do is close your eyes, take a few big deep breaths, and your brain will remember that you're sitting in a planetarium in San Francisco and not flying across the universe, at least not more than the usual. Hee hee hee. But with that being said, it looks like we're ready to go. So I invite you to sit back, relax, and let's begin our tour of the universe. Alrighty, folks. As I mentioned, we're going to be starting off pretty close to Earth, but not right exactly on it. We're just a little bit above it at this really cool contraption called the International Space Station. We can see the city lights of the Earth just down below. And also, the International Space Station likes to be abbreviated as the ISS. And a lot of people tend to ask me, hey, Christian, what is the International Space Station? I hear about it all the time in articles and news, but I don't really know what it is. Could you explain it for me? Well, of course, folks. Well, the International Space Station is a research facility, a laboratory that's orbiting around planet Earth. And a bunch of countries all across our globe came together to build this thing because they wanted to figure out what happens to things in space. So they get to conduct all different types of science experiments up here that they're unable to do while on the surface of the Earth. So some of the different experiments that they'll conduct up here are things like, what happens when you try to grow plants in space? Do the plants grow the same? Do they grow differently with less gravity? What happens when you try to spark a match in space? Does the flame act the same? Does that act differently? And one of my favorites is where they had two identical twins. One twin lived on Earth for about a year. The other one lived on the International Space Station for a year. After that year, they compared and contrasted. Turns out when you live in space for a very long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of body mass index. You lose a lot of muscles because you don't have gravity constantly working down on your muscles all the time. So if you're planning to live in space for a long time, remember to exercise daily. And also, folks, the International Space Station looks huge in our planetarium dome right now, but it's not that big in actuality. It's only about the size of an American football field. So if you've never been to an American football game, don't worry. You can also use the entire California Academy of Sciences, the museum that we're sitting in right now. That's about how big it is. And also, folks, what's really incredible is that this thing is going incredibly fast. It's going a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, folks, we look really far above our planet Earth, but we're not too far away either. We're only about 225 miles above the surface of the Earth. So 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. So not too bad. But folks, this is as far as we put humans out into space nowadays, only 225 miles above the surface of the Earth, because traveling into space is very, very expensive. You got to build yourself a rocket ship or buy yourself a rocket ship. And then once you get your hands on that rocket ship, you have to account for all the rocket fuel. And you're going to need a whole lot of rocket fuel. And once you get your hands on all that rocket fuel, you have to account for all the food, water, and all the air you're going to be breathing while you're up here in space. So the bill gets quite costly quite rapidly. But folks, the International Space Station is just the first stop of our tour of the universe. So let's see it slowly disappear compared to our planet Earth. We're going to lose it down below. And it looks like we're just hovering just above Saudi Arabia. So we're going to see them slowly disappear. And before we lose track of the International Space Station, I want to add a nice little orbital path so we can keep track of it. So there's that little orbital path. And let's zoom on out. Alrighty, folks, so we zoomed so far back now that we're looking down at our planet Earth. And before we continue proceeding on, I do want to let you know that the space program that I'm using here in the planetarium is something that you can go home and download if you want to try this out, if you like it. The space program that I'm using here is something called OpenSpace. So if you go to your favorite search engine, type in OpenSpace Project, then you can download this, give it a try. It's a whole lot of fun. But just a heads up, OpenSpace is in its beta phase, which means that we're not completely finished. It's not completely finished, so we may run across a few bugs and glitches. If we do, hopefully we can look past them. I'll point them out for you. And also, folks, if you have an older computer, you may not want to download this program because it may overwhelm it. OpenSpace uses a whole lot of processing power. So again, if you got an older computer, wouldn't recommend it. If you got something newer or a gaming computer, give it a try. It's a whole lot of fun. But also, if you're a person like me that doesn't want to download anything, we also have another great alternative called NASA's Eyes, just like the human eyeball. So go to your favorite search engine, type in NASA's Eyes, and you don't have to download anything. You can fly through space just like how I am, and it's a whole lot of fun. So we got OpenSpace and NASA's Eyes. But let's make our way over to our nearest natural neighbor to us in space, the moon. Now, folks, we humans have been to the moon before, but that was quite a while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they got to play some golf up here as well, so they had some fun. But again, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, we humans are planning to head back to the moon in the next few years thanks to NASA's new space mission called Artemis. Now, pretty much the whole goal of Artemis is that they want to send humans to Mars, but before we send humans deep into our solar system, we got to figure out exactly how we're going to live out here in space. So the moon is the perfect stepping stone to figuring out the logistics of how we're going to do that. And what's also really cool about Artemis is that they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're also going to be setting up lunar bases throughout the moon. So again, they're going to have lunar bases throughout the moon, which is also going to be really neat because let's say they want to, pretty much our technology has improved in the last 50 years. So we're able to conduct a lot more science than we were able to 50 years ago. So not only that, all of our science equipment's much more smaller, so we can bring a lot more stuff with us. But they're going to be setting up different lunar bases throughout the moon, places that we want to check out. One of the biggest ones is down in the South Pole, where one of the largest craters, or the largest crater impact site, is located on the very south side of the moon, South Pole. And what's also really cool is that they're going to have an they're going to have a space station that's going to be orbiting around the moon at all times. So kind of like with the International Space Station that we just saw, if anything was to go wrong while these astronauts were on the surface of the moon, they can launch off and head to that space station where they would be safe. So again, cross my fingers. Hopefully everything goes according to plan with that new mission Artemis. So look out in the news for anything about that. And folks, when we look at the moon here on Earth, sometimes the moon feels so incredibly close to us, it feels like you can reach out your arms and touch it. But the moon is incredibly far away from us. It's about 240,000 miles away from the Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it. The roads out here are poorly maintained. He. And from here on now, folks, we're going to need to use a more useful measuring stick, because at this scale, using miles is kind of like using inches to describe the distances between cities, because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like the same amount of time for a short pause in conversation. But at last, folks, it's time for us to leave the moon behind, so everybody say bye-bye, moon. We'll see you later. And now, folks, we're going to be stepping out into a much larger realm of our solar system, because now we're going to see the moon and the Earth as they slowly disappear. In fact, let me add some nice planet trails so we can keep track of stuff in space, because you can easily lose stuff out here. And folks, on our journey, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace, showing us the most accurate and information available to us. And folks, here comes the nearest star to us, the sun, comes into view. So here comes the sun. Do. And also, folks, the sun is also incredibly far away from us as well. So again, we're the third rock from the sun. So the closest one, 1, 2, 3. The sun's right there. Well, the sun is incredibly far away from the planet Earth. It's about 93 million miles between us. Whew, 93 million miles away. That's nothing compared to the speed of light, because in order for light to travel that distance, it only takes sunlight about 8.5 minutes at the speed of light. That's not that far at all. But this is a really cool concept to keep in mind, because let's say the sun was to turn off all of a sudden, no more sunlight was being emitted. That last bit of sunlight would travel that 93 million miles, that 8.5 minutes, and then finally that last bit of sunlight would reach the daytime on Earth, and then all of a sudden the daytime would become nighttime. Now again, this is such a cool concept to keep in mind, because this works for really far away objects in space as well. For example, let's say we're looking at a star that's 70 light years away from us. Well, we're seeing that star as it looked like 70 years ago, because that light just reached us right now. It took 70 years to get to us. So when we look at really far away objects out into space, it's like looking back in time in a sense. Pretty cool. But now that we have a nice bird's eye perspective of our solar system, let's do a quick refresher and see what's in it, because there's a lot of cool stuff here. Right in the middle, we have our star, the sun. The closest planet to the sun, we've got Mercury. Then we have Venus, Earth, that's us, and then Mars. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past the orbit of Mars, we have this really cool thing called the main asteroid belt. And this is what it would look like if I highlight all the asteroids in our asteroid belt. There is a lot of them. Give it a second. There we go. So that's our asteroid belt. And then past the asteroid belt, we have the really big planets. We have our gas giants, the Jovians. We've got Jupiter, the biggest one, Saturn. And then we have our icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we can always add everyone's favorite and lovable dwarf planet. So here comes the orbit of Pluto. So Pluto just popped up on the very right side of the screen right there. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering to yourself, what's the Kuiper Belt? I've never heard of that before. Well, folks, the Kuiper Belt's going to be all this stuff. So again, we are now looking at the Kuiper Belt, and this is past the orbit of Neptune. And you can kind of think of it like a second asteroid belt. What you're going to find out here are mostly icy asteroids and short period comets that don't stray too far away from the sun. And in 2006, we found more than 400 objects out here in the Kuiper Belt region, so we're still learning about what's exactly inside of our solar system. So as our technology improves, we're able to find more and more stuff way out here. So pretty cool. That's a pretty cool thing about science. We're constantly learning new things all the time. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And I want to put up on screen some of the different spacecrafts that we sent out in the 1970s to explore our solar system. So now on screen, we're going to have the trajectories showing of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. We can see that interaction right over here on the left. Now, all of these spacecrafts are traveling fast enough to escape the sun's gravity and leave our solar system behind, but even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for light to travel all the way out to the orbit of Pluto, it takes light about 5 hours at the speed of light to get this far. Only 5 hours. That's not that far at all, folks. But let's leave our planetary scale behind us, because now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us over 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. All right, folks, so now we're in interstellar space, and again, 4 years at this to reach the next star system to us. And let me see if I can find Alpha Centauri real quick. Always got to do a couple of fly arounds. Alrighty, so Alpha Centauri is going to be this one on the very far right over here. So we're right here. This is ours, the solar system, and then Alpha Centauri, 4 years between us. But that doesn't really put into perspective of how long it would take us humans to reach this star system. Well, if you're getting a rocket ship today, left our planet Earth, headed over to the next star system, it's going to take you about 8,500 years to cross that distance. Whew, and that's just a one-way trip. But folks, let's stop and consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside something called the radiosphere. So again, we're now inside the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. Now, this first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, folks, the radiosphere is always expanding at the rate of 1 light year per year, so is anybody out there listening? And right now I'm going to be putting up some markers on the screen. These markers indicate some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planet orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we've confirmed 5,000 exoplanets in the nearby vicinity to us, 5,000 other worlds besides our own. Whew! And that 5,000 number is going to be increasing as the years continue, because we have space telescopes where their whole purpose is to find as many exoplanets as possible. In fact, if you look in the very top left of our screen, you can see that we pointed our space telescopes in just one direction, and we found a whole heap of exoplanets just in that sliver of the night sky. So that 5,000 number, that's going to be going up. But to say if any of them are Earth-like with conditions suitable for life as we know it, well, we can't answer that question quite yet. Pretty much new space telescopes are being developed right now. So it's going to be a few years before those are developed and then launched, and then they'll be able to conduct science. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system on the left side of our radiosphere. We find an alien civilization all the way on the right side over here. We shoot them a text message. We say, hey, we're over here. Take 60 years to get to them. They listen in, answer back, another 60 years. That is a 120-year conversation in the making. Whew. And I can barely wait for a text message from my friend. Hee hee. But of course, folks, planetary systems beyond our radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. But I want to put away our exoplanet marker, but I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to the Milky Way galaxy. Alrighty, folks, so we're now looking down at our Milky Way galaxy, and can anybody see their house from here? Just kidding. So just to let you know, the Milky Way galaxy is incredibly large, folks. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light to cross the Milky Way. So that is enormous. But not only that, our Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If our recent discovery of so many exoplanets just within our small neighborhood, within this vast star city, is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way galaxy, I want to show you it from a sideways perspective. So we live in a flat spiral disk of the Milky Way galaxy. It looks like a big disk. And when you look up in the night sky, you probably heard a friend or somebody tell you like, hey, look, you can see the Milky Way galaxy. So what they're referring to is this. This is the Milky Way, the plane of it. Now, this is important because when astronomers and scientists want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south, instead of looking to the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So again, keep that in mind. We like to point our telescopes galactically north and galactically south. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So let's continue pressing on, and in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. Now, we live in a local galaxy group which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And folks, we've zoomed so far out now that we're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies, or voids where there's no galaxies at all. So we can see a nice galaxy cluster right over here. We can see a nice galaxy cluster over there. We can see very few galaxies over here and voids where there's no galaxies at all. So you can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, we've zoomed so far out now that the picture that we're looking at represents the closest 30,000 galaxies to us in space over 300 million light years across. We've got to give thanks to an amazing astronomy crew at the work at the University of Hawaii who spent decades compiling this amazing representation. So big shout out to them. But now, folks, we have automated systems that are even mapping the most distant galaxies. So now we're about to see the very large scale structure of the universe. And remember, folks, every single point of light that you're seeing, that's not a star, that's an individual galaxy. Whew, I feel small. And just a heads up, folks, the universe, or the large-scale structure of the universe, is not shaped like a bow tie or a butterfly. Once we swing around, you'll see that shape. Now, remember when I mentioned that we live in the flat spiral disk of our Milky Way galaxy? Well, if we were to line up our Milky Way, it would line up just like so, right down the middle. So again, we like to point our telescopes galactically north and galactically south. But astronomers still want to make sure that there was galaxies through the plane of our Milky Way, so we have this nice purple survey in the middle. You'll notice we're still able to find galaxies, just not as many and not as far. Pretty much, we have to wait for our technology to improve, and once that happens, we'll be able to map out all these regions that haven't been mapped out yet. So it's just a matter of time. We just have to wait for that technology. But folks, looks like we're running close out of time on our tour of the universe. 30 minutes is just not enough time to talk about the universe, so let's continue pressing on. Because now we're going to be heading out so far that we're going to be encountering these really distant objects known as the quasars. Now the quasars are going to be represented in these nice orange dots at the very edge of the large-scale structure. So we got quasars over here, quasars over there. And quasars are short for quasi-stellar radio sources, and these blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe, and before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. Alrighty, folks, so we're now at the very edge of the observable universe, and what we're looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. Now, all evidence indicates that the universe that we live in is about 13.8 billion years old, and this is data compiled by Planck and other radio telescopes. And the picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And what we're looking at is not a typical photo either. Instead, it's a temperature density image where the light echoes of the Big Bang are color-coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas the coolest, densest regions. Now, these fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these very small differences gave rise to that large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go, which is going to be back towards planet Earth. So let's find a nice entry point through all these quasars and galaxies. This looks like a good spot. And let's make our return trip back to planet Earth, y'all. Alrighty, folks, we're across an expanse of 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. And we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to peer into their telescopes and see into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we're making our way back to our Milky Way galaxy, folks. And we're making our way straight for that radiosphere. And of course, we're making our way downtown, walking fast faces, passing we're homebound. Da-na-na-na-na-na. And we're now approaching our star system, our solar system. Passing those spacecrafts we sent out in the 1970s to explore our solar system, passing the Kuiper Belt, and also making our way through the main asteroid belt, heading to the third rock from the sun, our homeworld, the only place we humans have ever called home. All the humans that we know and love all live on this one planet. And it looks like we're about to pass the orbit of the moon, the furthest we've ever sent humans out into space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. And I want to thank you all for stopping by and watching it with us today. I did hope you enjoyed it. But it looks like we made it back home safe and sound. And that's all for now, folks. Thanks for stopping by.